How's it going, everyone? In today's video, I'm going to be sharing with you 3 major bugs that you should avoid in Python. And this video will be especially helpful if you're just starting out in Python. I can personally say that I've run into each one of these myself when I was learning Python in my early days. So I hope this helps you to avoid making the same mistakes I did. Starting off with the most infamous one of them all. Is versus is equals to. Why do I consider this to be the most infamous? Because they feel like they can be used interchangeably in most situations, and Python won't stop you from using it in the wrong situations. For example, if we use both to compare text, we will get back the same result. And if we use both to compare integers, this can also return the same result, but not for the same reason, which can be incredibly confusing when you're first learning Python. Although in Python 3.15, I am quite impressed to see a syntax warning, which asks us if we meant to use is equals to instead of is. Also, before we continue, I'd just like to thank Zed for sponsoring this video. Zed is a lightning-fast code editor written in Rust, and I've been using it to do all my coding lately. If you feel like trying out Zed, I've left a link in the description box down below where you can download it for free. Anyway, let's get back to the video. It's incredibly important to understand that is used to compare identity and memory addresses, and is equals to is used to compare the actual values. This becomes far more clear when we start working with objects. So what we're going to do is create a simple data class that contains a name. And to do that, we need to import data class from data classes. Then using the data class decorator, we can create a class called person that contains a field called name. Then we can create 2 instances that contain the exact same information. As you can see, we have 2 Bobs here. Below, we're going to perform a comparison check and an identity check. And you'll notice that this time, one will return true and the other will return false. This is because is equals to is comparing the actual values, while is comparing the identity of the 2 objects. In other words, is comparing the ID of 2 objects. Since these 2 objects are completely independent and contain 2 completely different memory addresses, is returns false. As you can see here, the ID is different for both objects. And that's a very important concept to grasp. With small numbers or strings, you might get back a false positive when you use is to compare them. But this behavior isn't consistent and only works sometimes because of how Python chooses to optimize the storage of small data. So always use is equals to for comparing values, and is for checking the identity of 2 objects. Moving on to major bug number 2, shallow copying in Python. If Python's your first programming language, there's a good chance that this bug is going to bite you pretty hard the first time you try to copy a list in Python. So, suppose you have a list of elements like this one. Next, imagine you want to create a copy of this list. There are so many ways you could try to do this, starting off by creating a new variable and assigning the original list to it. The problem with this approach is that we didn't create a new list at all. We just created a reference to it. That means that if we modify the copy, we end up modifying the original as well. So here what we're going to do is append James to the copy, print the copy, and print the elements. And as an output, you'll notice that both of these lists contain the exact same elements, which shouldn't have happened. So you might move on to the next logical approach, using the built-in copy method or slice notation to create a shallow copy. Both of these approaches work just fine. They are functionally the same and create a shallow copy, but it's important to understand that a shallow copy might not necessarily be the copy you're looking for. Let me show you why. So next, we're going to append the value of 999 to elements underscore copy 1. Then we're going to print all of the lists. And as a result, you'll notice that the first copy successfully appended 999 to it. There were no issues here. But now let's try to append an element to this nested list in copy 1. So instead of appending 999, we're going to index the element at the index of 1 and assign, or we're going to append the value of copy 1 to it. This time, when we run the program, you'll notice that this ended up modifying every list that contained that nested list, including the original. All of these were affected by this one operation on the copy. And this is not a bug. Python performs shallow copies by default since it's far more memory efficient. A shallow copy only copies elements on the first level, but if a list contains any mutable objects, such as nested lists or dictionaries, those are not copied. They are only referenced. This brings us to deep copies. If you want to guarantee that every element in your list is an independent copy and not just a reference, you're going to have to create a deep copy. But remember, the trade-off for a deep copy is that it can consume much more memory since it has to create a whole new independent copy for each element in your list. The easiest way to create a deep copy in Python is to import it from copy. Then, to create a deep copy, we just call the deep copy function on the elements. And this creates an independent copy, which means the nested list has also been copied. And to prove that, we're going to attempt to modify it. So here we will try to append 999 to this list. Then we're going to print the copy and the original. And as an output, you should notice that only the copy was modified. And this is because we successfully created a deep copy of the original. And finally, major bug number 3. Mutable defaults in functions. This is a bug you will learn about pretty early on in Python, especially since most modern code editors will yell at you if you attempt to do this. Suppose you have a function that appends an element to a list. If no list is provided, it uses the default empty list. When we try to append elements to an existing list, our function is going to work as expected. So here we create 2 lists and we append some elements to it. As a result, we get our lists back with the new elements. But watch what happens when we force our function to use the mutable default. So in this example, we're not going to provide a list to the append function, and then we're going to call it a second time. Now when we run this, we're going to end up with 4 and 5, which is an interesting bug. This should not have included the value from the previous call, and yet it did. So now it's time that I explain what's going on here and how to fix this bug. When you create a function, Python only creates all the defaults once. This means that mutable defaults will always reference the same object when they are used. This isn't a problem for immutable types, such as integers or strings, but with mutable types, such as lists or dictionaries, you'll notice that the data will be shared between function calls. To fix this, we need to use an optional. So instead of saying that the target is of type list of integer, we're going to say that it's of type list of integer or none. And this will equal none by default. Then we need to explicitly check whether the default value is none before proceeding with creating an empty list. Then we can continue with the append logic. This check is incredibly important when you are creating mutable defaults, because we do not want this object to be shared between function calls. We want to be able to create a new list each time the user does not provide a target. And with that being done, we can run the exact same code, and this time we won't have that buggy behavior. So again, every time we don't explicitly insert a list to modify, our function takes care of creating a whole new empty list for us, which is pretty awesome. And with that, we've reached the end of this video. Do let me know in the comment section down below whether you've encountered any of these bugs or which bug gave you the biggest headache in Python. Otherwise, with all that being said, thanks for watching and I'll see you in the next video.